Classifying triangles. There are two ways to classify triangles: by their sides and by their angles. Today, we're going to be classifying triangles by their sides. Okay, so the first classification is scalene. Now, the reason a triangle would be scalene is because it has no sides that are the same length. Right? So that's what the definition is. And what would it look like? It would look like something like this, where this side has one line, this side has two, this side has three, indicating that they're all of different lengths. Now, a point of information that is not the definition, but goes with a scalene triangle, is that because the sides aren't the same, no angles are the same either. Because in order for the angles to be the same, at some point they would reach each other at the same length, and then therefore you'd have sides of the same size, because otherwise they wouldn't be able to touch. So in a scalene triangle, it is called scalene because no sides are the same, but also no angles are the same. The second kind of triangle would be isosceles, and the hardest part of isosceles is remembering how to spell it. An isosceles triangle has two sides of the same length. So an isosceles triangle would look like this, with these two sides the same length, and this one of a separate length. Now, an interesting fact about an isosceles triangle is that two angles are the same. And the two angles that are the same are those opposite the sides that are the same. So here's a side that's the same. This is the angle that's opposite, and this is the angle that is opposite. So the angles that are opposite the two sides that are the same have the same degree in terms of the angle. And this one being different at the bottom means that the angle at the top is not affiliated. The next type of classification by side, the last type, is equilateral. An equilateral triangle has all three sides of the same length. So these tend to be the little cute ones that have all three sides of the same length, indicated by those lines. But what's interesting about the equilateral triangle is that all three angles are also of the same length. And how much would they be? Well, it makes sense that they're all the same, because 180 degrees divided by 3 equals 60 degrees. So all three of these angles, and it doesn't matter how long the sides are, if they're 2 centimeters, if they're 80 centimeters, if they're 50 kilometers, the angles in between will always be 60 degrees. So let's try some examples. Classify the following. So in a question like this, it will give you a picture and it will ask you to tell me what each type is. And remember, they're not drawn to scale necessarily, so you have to use the information that you're given with the little lines to tell you what they are. So I'll give you a second. See if you get them. This one is equilateral. This one, even though it might look like it's isosceles because of the lines, is scalene. And the last one is isosceles. So that's one type of an example, but there's another type of example where, based on the information you gave and that those blue things about the angles, you could be asked to find angles. So, find the angles. First one, we have an isosceles triangle. This is 20 degrees. So you need to find A and B. So steps, justification. A equals 20 degrees, angles in isosceles triangle, okay, because the two that are opposite are the same, so they're the same. And then we go to B. B equals 180 degrees minus 20 plus 20. Why? 180 degrees in a triangle. So B equals 180 minus 40. So B equals 140 degrees. And remember, it isn't necessarily that things are drawn to scale. This triangle would probably look a lot more like that, but the idea is that you don't take anything based on what it looks like, you take it on the information that you're given. Okay, next type. If I had a triangle like this, and I was told that each side was 40 centimeters long, but I wasn't given any of the ones inside, then how could I find them? If they're all the same, that means they're an equilateral triangle. So angle A is equal to B is equal to C is equal to 180 degrees divided by 3. And this is all because of angles in an equilateral triangle. And so my answer is that A, B, and C are all equal to 60 degrees. C. So in this case, I know that this is a 92 degrees, and I know that this is a 45 degrees. This is a scalene, even though it kind of looks like it could be equal, is isosceles. it has the lines and they're not going to give me something that's equal. So in this case, I just have to do what we did before, 180 minus 45 plus 92. My reason, 180 degrees in a triangle. I have 180 minus 137, and that's going to give me 43 degrees. What if I had something like this? Okay, so that says 20 degrees. Here I have 100 and I'm looking for A and B. A equals B equals 180 degrees minus 20 degrees, but all divided by 2. And my reasons here would be 180 degrees in a triangle and angles in an isosceles triangle, because I know that all of them together have to be 180 degrees, but I don't know what the two that are the same are. So I have to subtract my 20 degrees, and then I'll have the two A and B, so I divide by 2. So A equals B equals 160 divided by 2, so A equals B equals 80 degrees.